Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, dear students. This is a revision for the module 103. This announcement in Arabic says that these data show slides only the test that we're going to discuss now, but the exam, the practical exam, can come from any slide, whether it's explanation or test. Dear student, we talked before that the body is formed of four basic tissues, which are the epithelial, muscle, nervous, and the connective tissue. We said that the connective tissue is formed of cells, fibers, and matrix. According to the matrix, if it is fluid, we're talking about blood. If it's firm, we're talking about cartilage. If it's hard, we're talking about bone. If it's soft, we are talking about connective tissue proper. This module, we're going to take the cartilage first. It's formed of cells, fibers, and the matrix. The matrix is firm. The cells, two types of cells, chondroplast and chondrocyte. The chondroplast is the cartilage forming and the chondrocyte is the maintenance. Both of them are protein producing active cells. The chondroplast is more active than the chondrocyte. The cartilage, three types. The hyaline cartilage, which is the most common. The yellow elastic cartilage, in which collagen type 2 and many elastic fibers are present. The predominating fiber is elastic, while in white fiber cartilage, the fibers is collagen type 1. Okay, dear students, most of the cartilage is surrounded with perichondrium. Perichondrium, which is formed of outer fibrous layer and inner chondrogenic layer. The outer fibrous layer is formed of collagen type 1 for muscle attachment, blood vessels, as you know that the cartilage is a vascular taking its nutrition by diffusion from the perichondrium. The inner chondrogenic, it's the mother cell for the chondroplast. Okay. The proliferation of the inner chondrogenic leads to a positional growth, increase in the diameter of the cartilage. Identify the tissue and be specific. This is cartilage. What type of cartilage? Hyaline cartilage. From where you know, here is the matrix. I cannot see any fibers because it's formed of collagen type 2. This is very fine and have the same refractive index as the matrix. Okay, number 2, I can see many cell nests. Okay, and this is covered or surrounded with perichondrium. The cartilage that's surrounded with perichondrium, either hyaline or elastic. I cannot see the elastic fiber and I have many cell nests. So it is hyaline cartilage. The black arrow points to the outer fibrous layer of the perichondrium. Okay, it's formed of collagen fibers and fibroblasts. The blue arrow points to inner chondrogenic or the chondroplast, which appears basophilic. Okay, the yellow circle is surrounding a cell nest. The red arrow is the matrix. Dear students, as I told you before, when you see any slide, please prepare a visible feature of identification. From where you know that this is the slide. We can ask you a visible feature for identification of the slide itself or a visible feature for an arrow, for example, the outer fibrous layer of the perichondrium. Okay, here is chondrocytes, and this is fibers, which appears as singly and as a single fibers, okay, zigzag, and surrounded with perichondrium, so it is elastic cartilage. Layer marked by the green star is the perichondrium. The blue arrow, either we can say inner chondrogenic or chondroplast. The yellow arrow is the elastic fiber. The elastic fiber runs singly, appears as a zigzag stained with arsine, special stain. The red arrow is the chondrocyte, which is basophilic, surrounded by a lacuna, any visible feature. Okay. The elastic cartilage present in the epiglottis, ear pinna, external auditory canal. Okay. Eustachian tube. Here is a cartilage, okay? That I cannot see the perichondrium. I cannot see perichondrium. I can see collagen bundles, and these are cells. Is this slide can mistaken for another slide? Yes, it could be mistaken for the white fibrous connective tissue. I can see the collagen fibers in the nuclei of the fibroblast. So is this nuclei or of fibroblast or chondrocyte? They are the chondrocyte, from where you know surrounded by lacuna, and there is a scanty matrix, basophilic scanty matrix. So it is white fibrocartilage. The green arrow collagen fiber type 1 appears acidophilic and in bundles. The yellow circle are the chondrocyte present in lacuna, appears basophilic, surrounded with scanty matrix. The white fibrocartilage is present in cartilage that cannot attachment between bones, no movement or limited movement, as in the intervertebral disc, mandibular joint, symphysis pubis, sternoclavicular joint. Again, this is a cartilage surrounded with perichondrium, and there are fibers. So it is yellow elastic cartilage. A is the chondrocyte, B is the elastic fibers. Okay, here is a cartilage. Identify. I cannot see the perichondrium, but the matrix here I cannot see fibers, and I can see cell nests. So it is hyaline cartilage. The asterisk is the matrix stained with metachromatic stain, and the yellow circle is cell nest. Where I can find the hyaline cartilage, which is the most common, in the respiratory passages to keep it patent all the time. I can see it in the fetal skeleton for shock absorbing, in the articular surfaces for smooth movement, in the epiphyseal plate, which is important for the growth of the bone. Okay, the second chapter is the bone. We have two types of bone, the compact and the spongy. Okay, the compact, I have two types of preparation, the decalcified compact and the ground compact. The bone is formed of cells, fibers, and matrix. The matrix is hard due to the position of calcium. The cells either osteogenic, which is the mother cell, osteoblast, which is the bone forming, osteocyte, which is the bone maintaining, and the osteoclast, which is the bone eating. Why do I want bone eating? This occurs during healing of fracture and during growth. Here, this is, I should say, whether it is compact or spongy. The spongy is formed of irregular bone trabeculae surrounded with bone marrow cavities, or in between them bone marrow cavities, while the compact, the functional and the structure unit is the Haversian system. What I can see here is the Haversian system, so this section is compact. What type of preparation? Is it decalcified or ground? Okay, if I can see it acidophilic, okay, and I can see the osteocyte inside the lacuna, it is decalcified. In order to deposit calcium, we put in an alkaline media. How? The osteoblasts secrete alkaline phosphatase that precipitate the calcium. If I want to remove the calcium, I put it in acidic media. This acidic media will remove the calcium, let the bone change it from the hard state to be soft, to be easily cut. This is decalcified compact. Name the structure pointed by the yellow arrow is the Haversian canal. The blue arrow is the osteocyte inside the lacuna. And this is the interstitial bone lamellae. where I can find the compact bone in the shaft of long bones surrounding the spongy bone. This is a section of bone. Okay, here is bone trabeculae, and these are bone marrow cavities. This slide is important. I want to identify different cells of the bone cells. We said we have osteogenic, which is the mother cell. It is present in the inner osteogenic cell layer of the periosteum and lining the bone marrow cavity. We have the osteoblast and we have the osteocyte and the osteoclast. How could I differentiate? The osteogenic, as we said, it is lining the bone marrow cavity in the endosteum, okay, and the nuclei appears flat. While the osteoclast present on the surface as well, but the nucleus here you can see it a little bit rounded or oval, okay. The osteocyte present in the matrix of the bone. The osteocytes should be present on the matrix of the bone. On the surface as well, I can see the osteoclast, which appear large and multinucleated. So the yellow arrow osteoclast, the blue bone trabeculae, the green arrow osteoclast. Okay, and this is osteocyte and this is osteogenic. Where I can find the spongy bone in the center of the epiphysis, flat bone, irregular bone. Here is the compact bone from where I know Virgin system. What type of preparation? Ground compact. What do I mean by ground compact? I let the cells die, okay, and I'm going to have something like a very sharp so I'm going to cut them into pieces, transparent pieces, and I'm going to put them on a slide, okay, not stained. What you can see is black, which is the air present in the tubes, which is Volkmann canal, Virgin canal, lacuna, and canaliculum. Identify the tissue and be specific. This is ground compact bone. This is ground compact bone. Identify the structure surrounded by the red circle is the Virgin system. The canal pointed by the red arrow is the Virgin, while the yellow arrow is the Volkmann canal. The Volkmann canal join Virgin with periosteum, and Virgin with endosteum. Okay, the blue arrow is the lacuna. Can I say it is osteocyte? No, the osteocyte is not present. It's not present. Okay, I can see only the lacuna, the air inside the lacuna. Okay, dear student, this slide, I can see collagen fiber and I can see these cells. Is this white fiber cartilage, or it is the white fibrous connective tissue? No, not this or that. What is this? Here is a structure surrounded with a periosteum. Periosteum, okay? Outer fibrous and inner osteogenic. Here are the collagen fibers, which is in the matrix of the organic components of the bone. And these are the osteocytes present in lacuna. What I can see here is the outer circumferential lamellae. Here it is decalcified compact bone and the visible feature of identification, not the Virgin system. Not the Virgin system. I can see the outer circumferential lamellae. Identify the tissue and be specific. Decalcified compact bone. Decalcified compact bone. Why? This is not white fiber cartilage because I can see this. Okay, this is the periosteum. If it is a cartilage, yes, I cannot see this in the white fibrocartilage. I cannot see the perichondrium. This is a periosteum. Number 2, why? And I can see the osteocyte inside the lacuna. The other was the chondrocyte inside a lacuna and separated by scanty matrix. Okay. Why this is not white fibrous connective tissue? Again, because it's surrounding with the periosteum. Identify the structure pointed by the yellow arrow, periosteum, the layer pointed by the green arrow, outer fibrous, while the blue is inner osteogenic or the osteoblast. The red arrow is the bone lamellae, we can say the outer circumferential lamellae. The red arrow is the osteocyte, and the red star is the bone lamellae, or we can say the outer circumferential lamellae. Here is decalcified compact bone. This is an easy slide because I can see the Habergen system. The red circle, Habergen system, the blue arrow is the Habergen canal, the green is the concentric bone lamellae, the red arrow is the osteocyte, and the yellow star is the outer circumferential lamellae. Okay, again, this is decalcified compact bone. Again, it's easy. This is the Habergen system. This is the Habergen canal, concentric bone lamellae. This is the osteocyte, and this is the interstitial bone lamellae. We can ask, as I told you before, visible feature of identification for the whole slide or a certain cell. This, dear student, is the spongy bone because I'm having a bone trabeculae separated by the bone marrow cavity. The yellow star is the bone trabeculae, the green star is the bone marrow cavity, the blue arrow is the osteogenic cell, okay, and the red arrow is the osteocyte. Here is the osteoblast. Here is the osteoblast. Okay, dear student, this is growing end of a long bone or the epiphyseal plate. Here is the resting stage, here is the proliferative stage, here is the maturation stage, here is the calcification stage, here is invasion, and here is spongy bone formation. Okay, again, the resting appears as the hyaline cartilage. The proliferative, the chondrocytes arranged in rows. The proliferative increase, the maturation increase in size. Calcification, the lacuna appears empty. Invasion, I can see RBCs. Spongy bone formation, irregular bone trabeculae separated by bone marrow cavity. The muscular tissue, dear students, we have data shows slide the skeletal and the cardiac muscle, and the skeletal we have both LS and TS section. First of all, I should know the type of a muscle. Is this skeletal or cardiac? From where I know, look at the nuclei. If the nuclei is peripheral, we are talking about skeletal muscle. Then this is TS or LS section. This is TS section. This is TS section. I'm going to explain it. Bismillahirrahmanirrahim. If this is the muscle, if I cut it TS, it appears polyhedral or rounded. Okay, again, this is the muscle. Okay, if I cut it LS, it appears as strips. Okay, so this is TS section. I can see the connective tissue covering. The outer connective tissue covering around the whole muscle is the thick epimysium. Between the bundles, perimysium. Between the fibers, endomysium. As you can see, the muscle fiber is acidophilic as it rich in mitochondria and myofibrils and smooth endoplasmic reticulum. And the nuclei is peripheral. Okay, so it is TS skeletal muscle. Curved arrow is the perimysium. The green arrow is the muscle fiber. The blue arrow is the epimysium. Here is cardiac muscle and another type of fibers, which is the Purkinje muscle fibers, which appears larger, paler, and this is the peripheral myofibril. This is a type of a muscle, and this is another type. Type A here, they are cylindrical, okay, regular, transverse striation, multiple peripheral nuclei. So A is LS section in skeletal muscle. While B, I can see the cylinders that branch in anastomose and the nuclei single and central, and I can see intercalated disc. So B is LS section of cardiac muscle. Again, this is a TS section in skeletal muscle from where you know the peripheral nuclei. So the circle is TS in the skeletal muscle. The blue arrow is the perimysium. Perimysium. The green arrow is the nuclei. Okay, what's here is the endomysium. Here is the muscle fiber appears cylindrical. I can see multiple peripheral nuclei, so it is skeletal muscle, LS skeletal muscle. The visible feature of identification, multiple peripheral nuclei and clear transverse striations. This is a muscle fiber, this is the endomysium, and this is the transverse striation, and this is the multiple peripheral oval nuclei. Here, dear students, is a muscle fiber that branches anastomose. The nucleus is central and single, and this is intercalated disc, so both of them is cardiac muscle. This is an LS section in cardiac muscle mentioned to visible feature of identification. The muscle branch in anastomose, the nucleus is central and single, and there is intercalated disc. The blue arrow is the intercalated disc, while the black circle is lipofuscin pigments, which is the residual bodies that present inside long lived cell as the cardiac muscle cell. The red arrow is the endomysium, and the yellow arrow is the nucleus. Dear student, this is cardiac muscle. The blue rectangle is the yellow rectangle is the cardiac muscle, and the blue circle is the Purkinje muscle cells. The Purkinje, the cells are larger, paler, and have a peripheral myofibrils. Three visible features we have: it is larger, paler, the peripheral myofibril. And the yellow rectangle, not the black. The yellow rectangle is the cardiac muscle. The last chapter we're going to talk today in this module, the skin. We have either thick skin and thin skin. The thick skin is formed of thick epidermis, has thick epidermis, no hair follicle or sebaceous gland. We have stratum basale, stratum spinosum, stratum granulosum, and stratum corneum. This is thin skin, from where you know the hair follicle, the sebaceous gland, and thin epidermis and thin horny layer. thin skin, epidermis, hair follicle, sebaceous gland, and dermis. What this section? It is thick skin. From where you know? Thick epidermis, thick horny layer, regular dermal papillae, no hair follicle, no sebaceous gland. The black line is the epidermis. The black triangle is the papillary layer of the dermis. The red star is the dermis. The blue arrow is stratum spinosum. The green arrow stratum basal, and the yellow arrow is the stratum granulosum, while the yellow star is the stratum corneum. Okay, dear student, this is two sections. One is type of skin and the other is another type. Type A is thick skin. Why? Thick epidermis, thick horny layer, regular dermal papillae, no hair follicle, no sebaceous gland. The yellow star, the white star is the stratum corneum. Look here, dear students. This is thin skin. Why? Thin epidermis, irregular dermal papillae due to presence of hair follicle, and sebaceous gland. The yellow arrow is sebaceous gland, and this is the hair follicle. Thank you, dear students, and good luck.